Alright, so now we are doing f of x, part C, which is f of x is equal to a piecewise function now. X squared minus x minus 6. Don't fear piecewise. Piecewise functions are the best friends of everyone in Clarify. You know why? Because they help you to really do well. Okay? 3. And I mean, this is if x is not equal to negative 2. Then this is only 3 if x is equal to negative 2. Okay? Oh, this is a very weird thing, right? All right, so now let's, we'll be just saying now, you can say f of x, for continuity, you can now say, let's put it, for continuity, we just use the continuity equation, okay? It does everything for us. For continuity, you can now say, maybe if you could put on the same line, still fine, you can say, this is what? F of x, so you can say f of, for continuity at x equal to negative 2. Let's put it there. To now say f of negative 2 should be equal to the limit of f as x approaches negative 2 of f of x. Okay? So now let's start by putting f of negative 2. Okay? Let's see. When are we going to do that? So we can say when for x equal to negative 2, f of x is, which one is it? If for x equal to negative 2, it is this one, f of x equal to 3, okay? F of x equal to 3. So you can now say f of x is equal to 3, which means f of negative 2 is just 3, okay? Okay, so this is the solution. Sorry for that. This is the solution for f of negative 2, okay? We wanted to know which f of x are we going to pick, this one or this one. So we use the value of x we are at. Remember, we are testing continuity at x equal to negative 2. So we are going to say x equal to negative 2. We come to the two conditions to see which function to pick. Here, when x is negative 2, you pick this function because that's the one which is taking it. And it's the function that says f of x is equal to 3. So that is why we say for x equal to negative, f of x equal to 3. So we can say f of x equal to 3, which means f of negative 2 is also equal to 3. Then now we are now saying the limit is x. The limit, now we are now saying for limit as x, limit as x goes, limit as x goes to negative 2, because we are doing the limit as x goes to negative 2. But since it's piecewise, we come from the left and then from the right. We can say from the right of f of x now is going to be the limit as x goes towards negative 2 from the right, right? And x is going towards negative 2 from the right. What are we going to choose as our f of x? Well, if we are going towards 2, but we are not negative 2, then it is always going to be this one, okay? Because you can see this is only when x is negative 2, right? So whenever x is not negative 2, it's going to be this one. So we'll be getting this. So we can say this is the limit as x goes towards negative 2 from the right is equal to the limit as x goes towards negative 2 from the left of f of x. Okay, and this is just going to be equal to, why did we say it's the same as them? Because the limit is, okay, let's get them one by one. So the limit as x goes towards negative 2 from the right is going to the limit as x goes towards negative 2 from the right of, who are we picking as our f of x? We are picking this x squared minus x minus 6. So it is x squared minus x minus 6 all over x plus 2. The thing with piecewise function is, the secret is you have to pick the right function, because there are two functions. There will be two functions. So you have to pick the right function depending on where you are. So here, this is a different one because we don't have one like the other piecewise functions where they say when x is less than, then or equal to, then when x is greater than. No, here they have when x is every other value which is just not negative 2, which means when it's less than negative 2 and when it's greater than negative 2. This one is only when x is negative 2. So you see, so now we'll be saying, okay, what is it when x is coming from the right? We can now say this is going to be, because from the right for this one is going to be the same as the one from the left, because we know that if we are coming from the right, we pick this because it's the one when x is not -2. If we're coming from the left, we pick this again because it's the one when x is not -2. I hope you understand for this situation. So this is going to be, that's why we don't have to work them out separately. But for other piecewise functions, you have to work them out separately to say from the right and then from the left, and then check if the answers are the same. Then you'd know that the limit exists. Then you'd come and compare the limit with this answer, because the limit should be equal to this answer. So that is what happens. So anyway, this is coming from the right. What do? X is going towards -2. We try to put -2 in here. It'll be -2 plus 2. That'll be 0. So we can't substitute it. So we try to change something, which is to factorize, obvious. So we can say the limit as x goes towards -2. Okay? You can still say from the right. Let's factorize. What do we have? -6. We put it on our t. We put the factors of 6, which is 1 and 6, 2 and 3. The next number after 2 is what? Is 3, which is already there, so we stop. Now we can see that this is a negative, which means that 1 and 6 are going to have different signs. 2 and 3 are going to have different signs. We come here, we check the sign of the bigger one, of the middle number, which is negative. That's the sign of the bigger number. So 6 will be negative, 3 will be negative. Which one would add to give us a -1, which is the value there? If we say 1 minus 6, we get -5, so it's out. 2 minus 3, we get -1, so it's 2. So we're going to have x plus 2 multiplying x minus 3, and it's all over x plus 2 like this. Okay, so what then happens is we cancel out this x plus 2, and so we will now have the limit as x goes towards -2 from the right of x minus 3, which is as we go towards a certain value. If that is not a fraction, we just substitute. So this is going to be, where there's x, you're putting -2, so it'll be -2 minus 3, which is just going to be -5. And this is going to be the final solution, and we are done. Okay, now we can keep going and keep going. Come on. So now what we know is that we can say that the limit as x goes towards -2 from the left of f of x is going to be the same as the limit is going to be equal to -5 as well. Okay, because you can now say then the limit, if you want to do it the longer way, you can do it, but this is still the limit as x goes towards -2 from the left of which fraction do you pick? You just show that you pick x squared minus x minus 6 all over x plus 2. So you can now just say, so this is just going to still give you an answer of -5. So you can now say limit as x approaches 2, you can say therefore, first you can say since limit as x approaches -2 from the left is equal to the limit, or this is of f of x, is equal to the limit as x approaches -2 from the right of f of x, which is equal to 5. Okay, you can now say therefore, can now come and say therefore, right, limit as x approaches -2 of f of x is going to be equal to 5. So now, because the left and the right hand functions were the same, so now we can just then say what was the other solution here? F of -2 is equal to 3. So f of -2, we got it as a 3. So this becomes a problem. So now you can now say f of -2 is not equal to the limit as x approaches -2 of f of x. Therefore, f of x or function is not continuous. Okay, so you can now say therefore f of x, which is, you can put the two things if you want, x squared minus x minus 6 over x plus 2 if x is not equal to -2, and 3 if x is equal to -2. We can say therefore this is not continuous at x equal to -2. And we are done. This is going to be the thing. And we would have proved it because the continuity equation has failed. Okay? This is the thing, and you have done. These are your solutions, and that's it. Okay? Goodbye for now. See you in the next video.